objective for today, I can write and evaluate powers. Let's read together. 1, 2, 3. I can write and evaluate powers. So, by looking at it, think about this question. What is the concept for today? And tell your neighbor. What is the concept for today? Okay, powers. However, we already know what powers are. The only thing we named them something different. So today I'm going to clarify that. So check this out. You only copy the objective at the bottom left for your Cornell notes. You don't copy this next Frayer model. You don't need the box. You don't need the Frayer model. Okay, here it goes. So I can write and evaluate powers. What are powers? Don't copy this, just focus. Pay attention. Powers are expressions that can be written with an exponent and a base. Powers are expressions that can be written with an exponent and a base. Focus, please. Examples. Does it have a base and an exponent? Yes. That one. Yes. That one. Yes. That one. Yes. How about these? No. That's why they're non-examples. So what is the most important thing to remember that powers have? Exponents and bases. Are we there? Yes. But you're saying, Mr. Q, don't we already know this? Yes, because I introduced them like this. Exponential expressions. Remember that? Aren't they the exact same thing? But the definition I gave you was a little bit more precise. It was a, bless you, a numerical variable expression raised to the power greater than 1. A numerical variable expression raised to the power greater than 1. Okay? We already have these notes. So, steps. I do want you to copy these, please. To write and evaluate powers, number 1, identify the repeated factor, which is the base, and count the number of times it multiplies itself, the exponent. Step 2, compute the factors, which means multiply out. Compute the factors, which means multiply out. Step 3, simplify, which is write the value without exponents. Write the value without exponents. And as you're writing those steps down, things to remember, I want you to circle identify and underline base, underline exponent. Step 2, circle compute. What does compute mean? Underline multiply. And step 3, simplify. Simplify. So, once again, we got the steps down, and here just to clarify, this is the base, and this is the exponent. All right? So let's move on. Copy this one down, example 1A, and write the power represented by the geometric model. Now check this out. I'm going to help those of you that are artistically challenged. Here it goes. First, let's sketch a square. Yeah, underneath the steps. Here it goes. Sketch your square. Focus, please. From there, you draw from this corner, draw one line down like this, to the back. From this corner, the same type of line on the same direction. And then from this corner, one more line back in the same direction. No? And then from there, you connect this one to this one to that one. Copy that, please. Okay, here we go. So it says, write the power. We already know what a power is, right? An expression that has a base and an exponent. So look at this. What would be the, think about it, what would be the power for this representation? Tell your neighbor. Who said 5 cubed? Okay, not bad. So let's find out why it's the power, because the powers have what? Base and exponent. Did it say to simplify? No, just write the power. Okay? So, with that said, copy this next one down, please. 1b. Okay, let's see. It says, write the power represented by the geometric model, and we see it's a square, so therefore this is 1 times 1, which can be written as 1 squared. Hands if you got that. Okay? Copy this next one down, please. Copy those two. Once again, for my artistically challenge, this one, you sketch a square first. From there, from this corner, you draw a line diagonal back like this. This one, the same direction, same length. And this one right here, same direction, same length. And then just connect this one to this one. And this one to that one. Okay, now check this out. Notice that the top one does not have values, does it? If it doesn't, let's just say that this one is, this measurement right here is 1 unit. So what is this measurement? 1 unit. So what is this plus this? 2 units. So let's look at this one. What is this measurement? 1, and this one? 1, so therefore this is a total of 2. So now, write me a power for this, and write me a power for that. Okay, let's see. For A, who saw that it was 2 by 2, therefore it's 2 squared. Okay? This one is a cube, so therefore this is x times x times x, so therefore this is x cubed. Hands for that one. Okay? So, next, copy this next one down, please. Oh, not this. Okay? Let me clarify on this one. Everybody pay attention, please. Pens down. Okay. Here it goes. And I'm going to make my font a little bit greater for this one so you can memorize it. Now, this is the common mistake that we're making. Check this out. We know that 2 could be written as 1 times 2. Is that correct? Also, check this out. Negative 2 could be written as negative 1 times 2. Everybody with me so far? So therefore, check this out. Let me bring the font back down. Therefore, I told you the other day that negative 2 to the second power was not the same as parentheses negative 2 to the second power. So let me show you why. First of all, look at this number. Everybody look up to the screen, please. Can I rewrite it? Look at this one. Can I rewrite it? Yeah, so I can rewrite it as negative 1 times 2. And what is the power on the 2? 2. Everybody see that? Okay, let's look at this one. And we're still saying this is not the same as that. Look at this one. This is saying that we need to multiply this factor to how many times by itself? Twice. So therefore this is negative 2 times negative 2. Are we there so far? Okay, so let's see. What is negative 2 times negative 2? Positive 4, because both have the same sign. Let's look at this one. Using order of operations to the powers first. What is 2 squared? 4 times negative 1, that's negative 4. Do you see how negative 4 is not the same as 4? Okay, are we clear with this? All right, with that said, copy this next one down, please. Copy those, please. So let's look at A. It says, simplify each expression. So this tells me to multiply whatever's inside of the parentheses how many times itself? 3. So therefore, This could be written as negative 6 times negative 6 times negative 6. Is that correct? Okay. So therefore, let's see. Negative 6 times negative 6 is positive 36. And we still need to multiply times negative 6. Positive times a negative. They're not the same sign, so the answer is going to be a what? Negative. Now I'm going to do my computation. I'm going to do that over here. 36 times 6. 6 times 6, that's 36. I got 3. 6 times 3 is 18 plus 3, 21. So that's 216. So this becomes negative 216. Okay. Move on. You ever see what we did? Okay. Let's look at B. This one. Be careful with this one. Do you see how the negative 10 is not in a parentheses? Can we rewrite it? Yes, this is negative 1 times 10 times 10. Do you see it? Check this out. Negative 1 times 10 times 10. Okay? This could be negative 1 times 10 to the second. Is that correct? Let me go back to what I just explained in a little bit. Look at this one. We know that negative 2 is the same as negative 1 times 2. Is that correct? And we wrote negative 2, this one, as negative 1 times 2. So with this one right here, negative 10 could be written as negative 1 times 10, and that's to the second power. So here it is, negative 1, 10 times 10. So far, so good? So what is 10 times 10? 100 times the negative? Negative 100. Copy that, please. Okay, copy that one, please. Okay, let's do this one together. Let's see. Now, there's two ways of doing this one. I'm going to do it first, showing you that the exponent tells us to multiply this times itself how many times? 2. So this is 2 over 9 times 2 over 9. Is that correct? So, let's see. What is 2 times 2? 4. What is 9 times 9? 81. Now, I gave you a property for exponents. Remember that? What do I need to write here? A 1, and here? A 1. If I was to distribute the power to the exponents here, this becomes 2 to the second over 9 to the second. Is that correct? And isn't this the same as 2 times 2 over 9 times 9? Which gives me 4 over 81. Here we go. Let's see, do those by yourself. See what you get. Check the work. So here we go. The first one could be written as negative 5 times negative 5 times negative 5. What is negative 5 times negative 5? 25 times negative 5, that's negative 125. This one, before you make the mistake, notice that the negative is outside of it doesn't have a parentheses, right? Can we rewrite this as negative 1 times 6 squared? Yes, right? So therefore, this becomes, let's see, negative 1 times 6 times 6. And what is 6 times 6? 36 times negative 1, that's negative 36. Okay? Copy that one, please. Focus. Okay. For this one, you should have written hold on, 3/4 times 3/4 times 3/4, which is 27 over 64. Okay? Answer if you got that one by yourself. Okay. And the last one, there's one word problem. Hold on. There's this one. Check this out. No, don't copy, pay attention. Check this out. This says, write each number as a power of a given base. What base do they give us? -8. So they want us to write a power that gives us how much? So think about it. Don't say it out loud. What goes there? Think about it. All right? I see a lot of you saying, who said 2? Okay, and let's look at this one. Once again, don't say it out loud. The base is -3. That means I need a parenthesis, and I need an exponent here to give me what? 81. Think about it. What number goes there? Think about it. -3 times itself. How many times give me 81? Who said 4? Okay, hold on. And the last one, so that you have an example of the next one. Give me a second. How about this one? Check this out. It says, school closing, in case of a school closing, the PTA president calls 3 families. Each of these families call 3 families, and so on and so forth. So what's the increment? 3. So guess what? That's going to be our base. How many families will have been called in the 4th round? That's going to be our exponent. So therefore, this becomes 3 times 3 times 3 times 3. So how many families? 81. Homework. Page what? 20 what? Numbers 1 through 18. Have a good one, guys. Enjoy your homework. See you guys tomorrow.